Imagine a planet about the size of Jupiter. It orbits a dead star roughly the size of Earth. A year on this planet lasts just 34 hours, and it sits less than 3 million kilometers from its star. But that's not even the strangest part. This planet should not be there at all. When its star was dying, it expanded into a red giant. If the planet had already been on its current orbit back then, it would have been buried deep inside the star's scorching outer envelope, and it almost certainly wouldn't have survived. But the planet is still there. It's called WD 1856b, and in 2026, the James Webb Space Telescope found a clue in its atmosphere that allowed astronomers to reconstruct events that happened billions of years ago. And this story matters to us for more than just the fact that there's a very strange planet about 80 light years away. Because our own star will eventually go through a very similar ending. And a recent study has taken another look at what that could mean for Earth. It turns out, Earth might survive too. But here, the word survive does not mean what you probably want it to mean. Today, WD 1856 plus 534 is a white dwarf. That's what remains after a roughly sun-like star reaches the end of its life. For billions of years, a star like this steadily fuses hydrogen into helium and lives a relatively quiet existence. But the fuel in its core is not infinite. When the hydrogen begins to run out, the structure of the star changes. Its outer layers start expanding. The star becomes a red giant. Later, it sheds a large fraction of its material into space, leaving behind an incredibly dense, hot core, a white dwarf. Its mass can still be comparable to the Sun's, while its size becomes comparable to Earth's. The result is an object of almost absurd density, and orbiting one of these stellar remnants, we found WD 1856b. The planet itself is roughly Jupiter-sized, but its star is now so tiny that the planet is about 7 times wider than the star. It almost looks wrong. A huge gas giant orbiting a tiny glowing point, and it does it fast. One complete orbit takes only about 34 hours. The real problem appeared when astronomers tried to rewind the history of the system. Because WD 1856b's current orbit passes through a region where, during the star's giant phase, a planet could not safely have existed. Which raised an obvious question. If the planet couldn't have been here before, how did it get here now? After the planet was discovered in 2020, there were several possible explanations. One of the more dramatic ideas was that the planet somehow survived an encounter with the star's enormous giant envelope. But there was another possibility. Maybe WD 1856b wasn't close to the star at all. Maybe it survived the death of its star, far out in the system. The star became a white dwarf. Billions of years passed, and only later did something knock the planet out of its distant, stable orbit. The problem was that both scenarios described events we can no longer watch. The star died billions of years ago. There was no camera there. But it turns out the planet itself preserved a record of what happened in its heat. In 2026, the James Webb Space Telescope observed WD 1856b. When the planet passes in front of the white dwarf, some of the star's light travels through the planet's atmosphere. Different molecules absorb different wavelengths. So by looking at which parts of the light are missing from the spectrum, astronomers can work out what the atmosphere contains. Webb detected signs of hydrocarbons. The best explanation for the spectrum was methane. The data also point to atmospheric aerosols. No aliens, no second Earth, just the atmosphere of a gas giant, although one in an extremely unusual place. But the spectrum allowed astronomers to do something else, estimate the planet's temperature. And that's where things stopped adding up. WD 1856b has an effective temperature of roughly 390 to 412 Kelvin. That's well above 100 degrees Celsius. But from the light of the white dwarf alone, the planet should be heated to only around 160 Kelvin. And this is a very old system. A gas giant this old, with no additional source of energy, should have cooled much more by now. But it hasn't, which means that, relatively recently in cosmic terms, something heated the planet dramatically, and it is still radiating that leftover heat into space today. This is where the real detective story begins. If WD-1856b received that extra heat when its star died, then the heating should have happened soon after the star became a white dwarf. But the cooling models tell a different story. The temperature we see today is more consistent with a major heating event that happened roughly 3 to 5.5 billion years after the star finished its giant phase. In other words, the star had already been dead for a very long time. The system had already spent billions of years around a white dwarf, and only then did something major happen to the planet. That makes the late migration scenario much more convincing. WD 1856. B probably survived the death of its star far away from it, and later gravity began rearranging the system. Other stars nearby could have gradually stretched the planet's orbit into a highly elongated one. At first, the planet stayed far away. Then it began repeatedly plunging close to the white dwarf, before swinging far back out again. Every close passage produced powerful tidal flexing. The star's gravity stretched and squeezed the planet. Material inside the planet moved and deformed. Orbital energy was converted into heat, and with every passage, some orbital energy was lost. The orbit became smaller, rounder, smaller again, rounder again, until eventually, WD-1856b ended up where we see it today, on an orbit lasting just 34 hours. So Webb essentially detected the aftermath of an event that happened billions of years ago. Not a photograph of the past, a thermal scar left behind by it. And this is where the story starts to matter to us, because WD-1856 demonstrates something important. The death of a star does not necessarily mean the end of its entire planetary system. Something can remain after the catastrophe. Orbits can change, planets can move, a planetary system can keep evolving around the remains of its star for billions of years. And one day, our sun will die too. In roughly 5 billion years, the hydrogen in its core will run out. The sun will begin to expand. It will become a red giant. Mercury is almost certainly finished. Venus too. Earth's fate, however, has remained much more interesting, because in Earth's case, two competing effects come into play. One is trying to destroy the planet. The other may help save it. As the sun swells, its outer envelope will approach Earth's present-day orbit. But the danger is not just the physical size of the star. A strong tidal interaction will develop between the giant sun and Earth. Essentially, Earth will begin losing orbital energy. And if that effect is strong enough, the planet will spiral inward, toward the sun. That is the bad side of the story. But at the same time, the aging sun will also lose an enormous amount of its own mass. Material will escape into space through stellar winds. As the sun loses mass, its gravitational grip weakens, and when the central object becomes less massive, planetary orbits expand, so Earth is being pulled inward by tides, while the sun's mass loss allows its orbit to expand outward, and Earth's fate depends on which effect wins. That is exactly what researchers recalculated in a 2026 study. In many older models, tidal drag was strong enough that Earth was eventually swallowed. But newer models of tidal dissipation predict a weaker interaction. In the author's baseline calculation, Mercury and Venus are lost, but Earth moves outward fast enough to survive the sun's giant phases. Mars survives too. So, for the first time, we have a physically well-motivated scenario in which billions of years from now, the sun sheds its outer layers, becomes a white dwarf, and Earth still exists, only now much farther away. That sounds almost optimistic, but it is far too early to celebrate a victory of rock over star, because the outcome is sensitive to a parameter we still do not know very well: how quickly the sun will lose mass during the final giant stages of its life. If it loses mass quickly enough, its gravitational grip weakens faster and Earth moves outward. If the mass loss is slower, tides have more time to act, and they may still drag the planet inward. There is uncertainty in the the strength of the tidal interaction itself as well. So the new study does not say, Earth is definitely safe. It says something much more interesting. With modern models, Earth's survival is physically possible, and may even be likely across a range of realistic assumptions. But the final verdict is still not in. Although for us personally, that verdict changes almost nothing, because there is one unpleasant detail. Earth does not need to fall into the sun to stop being Earth. The sun is already growing brighter over time, and long before it becomes a red giant, that increasing luminosity will radically change our planet's climate. The carbon cycle will break down, the modern biosphere will disappear, atmospheric oxygen levels will collapse. Later, surface conditions will become incompatible with complex life as we know it. Later still, Earth will begin losing its water, and all of that happens long before the planet's final confrontation with the red giant. So billions of years from now, the question will no longer be, will humanity survive, or even will life survive? The question will be much colder. Will the planet itself still be there? And maybe it will. Imagine that solar system. The sun as we know it is gone. At the center is a white dwarf roughly the size of Earth. Mercury is gone. Venus is gone. The orbits of the surviving planets have expanded. And somewhere much farther out than today, orbiting the remains of its star, is the world that used to be our planet. No cities, no forests, no oceans as we know them, no familiar sky, perhaps little more than an almost lifeless rocky world orbiting the remains of its own star. We are now beginning to discover planetary systems like this around other white dwarfs. WD 1856. B is not a photograph of Earth's future. It is a different kind of planet, a different system, a different history. But it shows us something fundamental. A planetary system can survive the death of its star. It can be disrupted, rearranged. It can lose some of its worlds and still continue to exist, sometimes for billions of years more. So yes, Earth may actually survive the death of the sun, but surviving does not mean staying the same. And long after the last trace of humanity has disappeared, somewhere in the darkness, there may still be a planet moving through space. A world that once had oceans, cities, and creatures capable of looking up at the stars and calculating the end of their own world billions of years in advance. So the real question is not whether Earth will still exist after the sun dies. It is this: after everything that happens to it, what will still deserve to be called Earth?